forgot I was going to do this. Maybe I can use it. Okay. Oh, this is the best part of class. Okay.
So did you have school tonight?
No. Again,
No,
this class is off tomorrow. Yes. I want to be really careful. I do not have the power. The power of gross mode. I do not have the power. Oh. All right, guys. So, really quick. Wow. I see that. There it is. Okay. There we go. So help me out, guys. How would I solve that equation there officially?
X minus 1 equals 7, and x minus 1 equals negative 7.
And then you got two little equations to solve. The absolute, no joke intended, the absolute biggest problem, mistake I see, let me label this as mistake. The biggest mistake I see with these kind of problems is somebody does this.
That's what I did.
So, I cannot take the absolute value of a number if I don't know what that number is. Do you agree? Yeah. So if I said, what's the absolute value of the number in my head? You're all like, who knows? What the shit? So, I don't know what x minus 1 is. If I just change the minus 1 to a plus 1, isn't it an entirely different number? You with me? What's 8 minus 1? 7. What's 8 plus 1? Totally different number. I've just completely changed what the equation wanted from me. And again, I'm not coming on you because a lot of people do that. It's a very common mistake because our brain says freaking absolute value makes things positive. Sure it does, but not a piece of a number. It makes the entire number positive, right? So what the hell is the idea then? How did we get to these two cases? Because you say to yourself, what do I replace this with to make this true? What could x minus 1 be? So the absolute value is 7. It could either already be 7 or it could be negative 7. That's where the two cases come from. Are you guys, does that make sense? So it's not like we're doing something, which is why I don't like absolute value, because it hides the fact that it's two functions. It's we're thinking, what would I put in there? I put a 7 or a okay, so the shit inside could be equal to 7, or it could be equal to negative 7. Does that make? So that's how I always get my two cases, right? Okay. Anything else from the quiz? Is that better? Okay. Yes.
And then if like the 7 was to be negative, that would be
exactly. If I now be careful, right? So if I had a absolute value equation that already had the absolute value by itself and it equaled negative 11, what's the answer?
no solution.
No solution. But if I have this equation, do I know if there's no solution yet?
You divide by negative 1.
Okay, yeah, you could, but let's see, subtract negative 3.
Oh, I didn't see the 3. I thought you meant that one.
And then divide by negative 1. So is this a valid equation?
Yeah.
One got real big. Total. So then I have to do it, yeah.
For the inverse, how it said f of x equals so and so x or y or equals y minus or x minus f of inverse. Okay, it said f of x equals square root of x minus 2 o plus 2. Can I just make that first? I make that y equals f of x automatically equals y. So I would make that y equals square of 5, 3x minus 1.
So the fifth root.
And then I would switch, the x to the y.
Yeah.
And then I would move the 7 over.
Yeah, then you just solve for
And then you just solve for y. Okay.
Yep. Dear God, if you're solving a problem like this and you get something like 2x minus 3 to the 5th power, do not multiply that shit out. You understand? Like here, I'm going to get a 5th power. Do you guys see that? Eventually I'm going to get a 5th power, correct? Because I'm going to have to kill the 5th root. So I'm going to get x minus 7 to the 5th power. Do not write that 5 times and multiply it out. Do you understand? You don't, there's, number one, there's no reason to. And number two, holy shit, I'm never gonna give you a problem where it's just that much busy work, right? I'm gonna give you a little bit of busy work, sure, just to make sure you can keep track of things, but no, I'm not gonna make you write, no. You guys kind of, even a third power, don't take time to multiply it out, okay? If you did, it's okay, you're not wrong, just don't do it, there's no reason. Anything else from the quiz while it's in your brain? Okay, alright, yes?
The second one that was a solve for, I think it was like 5 minus 3.
Sure, yeah, so that's like the one I did over here. The first thing you do is get the absolute value by itself, so you move it, you divide, you get the absolute value by itself, and then you can tell if it's got a valid answer or not. And then you can, now here it does, so I have to keep going, do the two cases, yes?
Okay.
What would the two cases be in this problem?
It would be 2x minus 1 equals 14, and 2x minus 1 equals negative 14.
And then you got two easy freaking equations, right?
Yeah.
Okay.
And then you check them. Because then you gotta check them.
Nope.
No?
Radical equations you have to check. Because we square, which loses information about whether something's negative or not, so we gotta check to make sure we didn't create.
Well, I check
New.
it either way.
You can check them, yeah, you can always check anything. Yeah.
If it was a negative 14, then there would be no solution then, if I got to that point.
Yeah, if you got to the point and instead of 14 it said negative 14, you could just stop. In fact, dear God, stop. Because you could keep going, you can get answers, and they're all wrong. Because there's no way in hell an absolute value can equal a negative number, right? Yes.
So the only one I might think I got wrong was, well, maybe finding the x coordinate. I found the y coordinate.
Oh, the intercept?
Yeah, the intercept. And then, I mean, I tried to plug it in the graph, and I was like, I couldn't find the exact one, you know? So then what I did was I might have done this wrong. I took the slope formula, plugged in the slope.
No, guys. So, all right. If I don't say graph, don't graph. Now you
No, I
can
didn't
graph.
graph. No. I said I did the slope formula, so the slope is 4 over 5.
Don't do that. So how do I find the x-intercept? Always.
It's
Make
the
y
is
zero. I don't know if I'm the y-intercept.
Oh,
X is
man.
0.
That's it.
Well, I think I did that. I actually did that with the slope.
Alright.
I
We'll
did
see.
that with the slope formula.
Sure. Okay.
So it worked. Okay.
All right.
Alright.
All right, guys. So, did anyone not get the updated homework sheet? And the only homework that was updated is there's 2 sections in green that are extra credit. Yeah, that's the worksheet we did yesterday is on the back of this. You're welcome. All right. So. I've got so many things. Yeah, let me do this before I forget. I'm going to go ahead and give you the practice test. Just, look at this for a second and put it away. I just want to give it to you before I forget. Oh, you got the actual book. Look at it. Sorry.
So if I made my y2 0 with the slope formula, that technically makes sense. That would be right?
Yeah, you can put the equation any form you want to, as long as you make x 0 and then 1 0.
Yeah, okay, I think it is that. Okay, that's good. Alright.
Everything is due by the day of the next test except homework corrections. That is the quick way to summarize all my mad due dates. Right? Okay. That's the practice list. We can just put that away for right now. Oh, Lisa? Aaron? Okay. Search party. Alright guys, so we're going to get into, so last time we talked about power functions, we talked about polynomials, we talked about degree of polynomials, yes? What makes something a polynomial? Let me make that more, what makes something a polynomial?
It has a power.
It doesn't have to have more than one term, no? So
It has a power, like an exponent.
it sure can, but a specific kind of exponent. Is this a polynomial? You ready? Why not?
Has to have
It
more than
has
one variable.
It's got a.
No, it
We got three
definitely
numbers.
It's
is.
not a rational.
The trinomial.
Yeah, all the exponents on the variables have to be to a whole number. Kick ass. So watch this, you ready? What degree would this be, by the way, if I took this away? Now is it a polynomial?
Yeah.
Yes.
Go away, you freak us out. What's the degree? 11th degree, and what kind of polynomial is it specifically? Binomial. I like it. I like it. Okay. And then, of course, what about this little dude here? 2x to the 7th plus 1/2 x to the 5th minus 3 over x.
Yeah.
Why not? Is there a problem with the 1/2? No, it's just a freaking number. All I care about is the powers or whole numbers. You would say x has a 1 on it, but you'd be wrong. Isn't it on the bottom? If I wrote it on the top, what would the power be? What makes something flip? So it's x to the -1. You guys see that? So that's not a polynomial. So why do we define polynomials like this? I want a polynomial to be defined everywhere. Is this one defined everywhere? Where's it undefined? What value can I not put into it? 0, yeah. Can't divide by 0, right? If you can, show me. Yes.
So, what about like y equals 4?
Okay, cool. All right. That's where it's going to go next. So what do you guys think about that? Is that a polynomial?
Yeah.
Let me ask you, is every variable
yeah.
you see to a whole number? Every single variable I see in there is to a whole number, yes?
This is a 0.
Beautiful, even better. There is an x there. It's just to the 0 power. What is x to the 0 power? 1. You guys kind of with me? Now, give me like a standard nice polynomial. Can anybody do that?
Wait, so that would be a
X
0
squared.
degree.
This is a
Plus.
0th degree
I thought it's a first degree.
monomial. Say again?
It's a first degree because of 4,
No.
4 to the first degree.
How many variables do you see?
That'll make it.
How many variables do you see?
1.
Where's the variable
no,
here?
No variable.
0 degree, yeah.
Oh.
What's the most variables I see in, if I take this away again?
If you made it to the first degree, wouldn't that make it 40? Would that be right? No?
All right,
It
so
would
real
have
quick.
to be 4.
Why is this an 11th degree binomial?
That
Why is
is
this
the
a large?
largest.
X to
Because
the
that's,
11.
yeah, that's
X
the
is to the
largest.
11th. Well, what a first degree require?
Just an
to the
X.
first.
Yeah, so is this a first degree polynomial?
Yes.
Yes, because the variable is to the first degree. The variable is to the first power.
Variable.
And would that be a monomial or a binomial?
How many terms are there?
2?
2.
Okay.
So that's a binomial. Okay. Side. All right. So it kind of makes sense. Real quick. Did this 7 bug anybody about this? Does it give anybody pause for a second? This is a polynomial, correct? I don't give a shit about the 7. So if part of this is, if this is polynomial, every piece of it has to be a polynomial. That's why constants are, there's another reason why constants are polynomials, because they're part of longer
And
polynomials.
it can't be the negative number. The power.
Power has to be a whole number.
Because then you're flipping it. Because it's-
Exactly, and that leads to possibly places where it's not defined. Okay. So the reason we give these things names, like polynomial, is so I can if I talk to a math colleague of mine and say, I got this polynomial I'm working on, they immediately know I could use whatever input I want to, it's gonna be nice and smooth. I don't know if you guys are with me. So there's other things about polynomials you'll learn as you go through mathematics, but the reason we call it that is I know a lot of shit just by saying that. Communicates a lot of stuff quickly. And one thing about math people is we like to communicate quickly, which means for everybody trying to learn the damn language, that makes it difficult because it's like a bunch of shorthand shit, yes? It is a totally different language. I get that. Okay. How are we feeling so far about this? Okay. We do one more example if I have more than one variable in something. You ready?
Sorry, what section is this?
Shoot. Yep. It's got two variables. How many terms are in this thing? 3. Is every variable to a whole number power? Yes. So is it a polynomial?
Yes.
Yes, good. Are we going to work with multivariable polynomials a lot? No. But I want to make a point. In that first term, how many variables do you see?
2.
2 x's and a y. So let me ask you again, how many variables do you see?
3.
30.
So that is a third degree term. Degree means the total number of variables I see in a term, right? And the degree of a polynomial is just the highest degree I see. So that's degree 3. What's this guy?
The fourth degree.
Fourth degree. And what's that guy? First degree. So what's the degree of the polynomial?
Fourth.
Fourth, because that's the highest degree I see.
Four.
What's the degree of the first term? I see 2 x's and a y. Degree means the number of variables I see in a term. So what's the degree of this first term?
3.
Third degree. What's the degree of the second term?
4th degree.
Fourth degree.
Oh, because the x and the y.
There's 3 y's, 1 x, that's
Gotcha.
fourth degree. And that last term?
First
First
degree.
degree. What is the highest degree that we see?
4th.
So what's the degree of the polynomial? Fourth degree. You guys with me now? Okay. And again, you're all worried about what the other terms do, but did anyone have any issues with this guy? When you told me it was 11th degree, did you worry about this guy? No, because you know it's the highest degree that you see. Same thing, I don't care how many letters I shove into here. It's the same idea. So what is, if I give you this thing, you see how much I can give you without you going insane.
So that one, sorry, the past one would be a fourth degree trinomial.
Fourth degree trinomial, I love it. What's the degree of this first term?
15.
Yeah, 2, 3, 4, 15. Degree of this guy?
5th.
No?
Or, no.
4.
Yeah. So the 7 doesn't count. It's a constant. So degree gives me an idea of how quickly it's going to grow. Would you all agree this sucker's going to, it's a negative, but still, it's going to grow very quickly? Because when I raise something to the 11th power, that gets stupid. That gets stupid big. In this case, negative. Unless I put a negative in. Okay. This guy's going to grow not as quick. This guy's not going to grow at all. Isn't it just 4?
Yeah.
So
Yes.
how would you describe the growth of this? No growth. 0 degree makes sense then. There's no growth. This, if I put shit in for all of these, it's going to grow really stupid fast. 15th degree. 15th degree. So what kind of polynomial is this? What's the highest degree?
15th degree.
15th degree
Binomial.
binomial. Kick ass. Okay. So the idea of degree is just the total number of variables I see. Counting repeats, right? 2 x's, 1 y, 1 z, 11 w's. Cool. Okay. So we talked about power functions. Power functions are just things that we can collect together and make polynomials out of. Right? Okay. I don't think this is weird. Hold on. There we go. I don't think there was anything else too much in that one.
Regarding the test, can you go over end behavior?
Yeah, there we go. End behavior. Okay. So help me out. If I give you this polynomial,
And is this still 5.2?
still 5-2. There's a lot of shit 5-2.
Okay.
All right, let me see.
This is all 5-2.
Still 5-2. Yep. All right. Third degree binomial. Get that out of the way. Can anybody tell me the end behavior of this?
It's gonna be like this.
Oh.
You gotta be careful about one thing. You're saying that because of the cube, right?
Yeah.
Which is beautiful. But what that term is negative.
It goes down.
Oh.
It's flipped upside
So
down.
it's gonna do, the end behavior would be this. The flip of what a cube normally would do. Are you guys with me?
Yeah.
So the highest degree term is what determines end behavior. Because when x gets really, really big, which term in that is the most dominant?
second one.
Yeah, because 2 is just 2, right? Even if I put an x here, this guy, when x gets really big, so when I make it a trillion, 2 trillion is big, but this is 7 times a trillion cubed. Holy shit. This basically means nothing then, right? That's why the highest degree determines what the end behavior is. Because the end behavior is when x is getting really big. And the one that's got the highest degree is going to dominate. Now, when x is small, this thing isn't as dominant. That's when it could do all this weird wiggly shit. Right? Which is what we still have to determine. Okay. So what about this one real quick? What do you got, Jeff?
Well, the last term is the big dominant one, it's the 6th degree.
So what's the end behavior going to be? You guys draw it in the air. What's the end behavior going to
It's gonna
be?
go,
Like a downward
or it's gonna go
parabola.
like, it's gonna go
So
like,
which term has the highest degree? The last one. So if it was positive, it would be this, but it's negative. So it's
down.
right. Yeah, that's all. You guys see what I'm saying? So when x gets really big, x squared and x to the fourth don't mean shit compared to x to the sixth. It's going to dominate. And it would look like a parabola opening down. So that determines the end behavior. The middle could be all wobbly, like we saw, but the end has to follow what the biggest dude is. I mean, what the most important dude is when x gets big. Okay, I like it. This is why we call it end behavior. The middle could do weird shit. Okay. Today we're going to talk about figuring out that weird shit. All right. God, this is freaking me out. Let me put this back. Okay. So what we're going to talk about today is how to actually graph these things where end behavior is just one thing I'll look at. So let me do this. Yeah. You can do it, Jeff. Can you? You can. Look at you go. Okay. All right, let's collect. So now, basically, section 5.3 takes a lot of what we learned and just kind of puts them all together. Yeah?
I was gonna go ahead and say, can we take out the x, factor it out?
Real quick, can you tell me the end behavior now?
Downward.
Well, yeah, it's gonna go
Yeah, what's the biggest power? What's the biggest power?
three.
Third power. So what does that look like? Cactus or cubish, right?
Oh yeah.
Cubish cactus. Okay. So I know, right now I know the end behavior is going to be this. It's not negative, so it's not been flipped. You guys with me?
Yes.
So this is a beautiful answer to what the hell the end behavior is. Just do this little bam. The book is, let me just point this out. Oh, I hate this about the book. The book says shit like, as x goes to infinity, y goes to infinity. So watch, when x gets really big, this way, what is the y doing? Getting really big
Also
positive,
rising.
correct? That's what that means. How would I describe this one? As x gets really small,
Y gets to negative.
y goes to negative infinity. Yeah. Or I should say, as x gets big, negative, right? So I don't need that from you. But just in case you see that in the book, that's what that means. The visual is actually much better. Okay. Okay.
Calc stuff.
So you,
Those for calculus.
you got
I
it.
have a lot of them.
Now I want to know the intercepts. Can somebody just tell me the y-intercept right now? Y-intercept.
0.
Yes, because how do you find the y-intercept? You make x 0, so it'd be 0, 0. Okay. Now, real quick, do you guys understand that is the one point that is both an x-intercept and a y-intercept? Because it's the one point that's on both axes, correct? Now, Philip, you had a good point earlier. How does what you said earlier relate to finding the x-intercepts? How do I find the x-intercepts? How do I find the x-intercepts? Make y 0. Okay, so I get 0 equals x cubed minus x squared minus 12x. And then what do I do?
Take out x. Take out
take out, yeah, factor, right? I love it when somebody says solve. I'm
You're
like,
gonna find three values.
can you be a little less
There's
specific?
gonna be three values for zero. It's gonna be three, or sorry, it's gonna
Well, let's
be
see. Take an x out, what do you get?
X
minus
minus X
minus
minus 12.
3, or x minus.
Don't try to think ahead too
4,
much.
X minus 4, x plus 3.
Alright, so 4 and 3 make 12. If I make the 4 negative, that makes negative x in the middle.
Yeah.
So what are my x-intercepts?
0, 4, and negative 3.
Alright, let me stop for a minute. This, yes, go ahead.
You screwed it up a little.
Get where now? Sorry.
To be x-intercept, or y-intercept, x-intercept.
This work here. Okay. To find the y-intercept, I make x 0. To find the x-intercept, I make y 0. Right? And how do I solve 0 equals stuff with higher powers than 1? I factor it, right? So you agree there's a GCF of an x? So if I take an x out, I got 2 of them left, 1 of them left, none of them left, correct? How do I factor this? 2 numbers that multiply to be negative 12, add to be negative 1, yes. Factoring needs to be right there. It's going to show up whenever the hell it wants to. It's got to be a little quick piece of the work. It can't be like the thing. Is that? And if it is right now the thing, you need to come see me. You need to get some help. You need to get that. Factoring is going to show up in so many places, and we just have to let it be something that we can do really quick on the phone. Right. So this guy is just the same old stuff as before. Then I can just read off my x-intercepts, right? Okay. So let's collect what we know so far about this thing. So I'm going to kind of copy down what we know. I know the end behavior. I know it goes through the points 0, 0, 4, 0, negative 3, 0.
Well, that wouldn't be enough because
We'll get some more. So let's kind of see what we know so far. We know very little so far,
we know the y-intercept as well, which is 0, 0.
which really isn't more information, right? Unfortunately. But I can plot 0, 0. My scale sucks, but too bad for everybody. 4, 0, and negative 3, 0.
Oh yeah, you don't know if it's going.
Now, guys, from the end behavior, I know it's going to start down here. You guys see that?
Yeah.
I don't have to plug points in. I know it's going to start down here. The trick is it going to turn or is it going to go through?
Go through.
So let me see. Let me write down our factored form again. What was it? Where'd it go? There it is. Okay. One thing I could do. Do you all agree with me? It would be really good to know not only what side it's on, but also how high or how low it goes. Do y'all agree?
Mhm.
There's going to be either a hill here. Does everybody see that? I need you. So it starts down here. It could either go through, in which case, does everybody see? It's got to turn around because it's got to get back down here, right? Okay, good. So there's some kind of peak, or if it turns, there's some kind of valley. So what's a good point to plug in to see where it is?
1, 1.
Somewhere, so either -1 or -2, right? Don't plug in
Yeah.
-1.5. That's just silly. So if I plug in, you tell me, what do you want to plug in?
-2.
-2. I get -2 times -6 times times 1. There we go. You guys all with me? If I make x -2, x is -2.
Find the y.
-2 minus 4 is -6. -2 plus 3 is 1. So what do I get for y?
-5. Oh wait,
Well.
mine, I'm sorry, I had it. What are those?
What is this?
12.
12.
12. Oh, that was right.
So I know it's going to be up here somewhere, right? You guys kind of with me?
Yes.
So it looks like it's going to go through, reach a peak somewhere in here. It's not necessarily 12, but you know, it's the most we know.
So the point is -2, 12. Or -2, 12.
Yes. And then it's going to come back down, and then either it's going to turn or it's going to go through, and then again it's going to have either a peak or a valley over here.
That
What's
way.
a very good point to plug in over here? 2. So if I plug in a 2, what do I get? I get 2. What do I get? Plug into 2, yep. Negative 2. Fine, I love it. And what's that? Negative 20. Good. So now we know it goes through negative 2, 12, and 2, negative 20. Okay. Now I'm going to tell you a bit of a shortcut about things, but I just wanted to go through this with you. I don't have to plot a bunch of points. I just have to plot a couple. Because I know it's going to come up from below. I know it's going to end up going up over here. I already know that from the end behavior. I need these points. Notice which axis have I not done a damn thing to yet. I can't until I know some outputs so I know what kind of scale to make. What if one of these outputs was negative 1,000? Holy shit, I'm going to need a stupid big scale, right? I don't want to 1, 2, 3, 4, 5, 6, tape, paper. So what kind of scale do you think I want to use on the y-axis to get to the points I need to?
20, 25.
What kind of scale though? Go by 20s or
Oh,
go by...
Go by 4s, maybe?
4s are good because 4 goes into both, right?
Yeah.
It doesn't matter. Use 5, 6s, just not 1s. That would be silly. You don't want to lunge over up to 20. So I can go 4, 8, 12, 16, 20. 4, 8, 12, 16, 20. So now I can plot my points, negative 2, 12, and 2, negative 20. Can you see how this is taking shape now? It's coming. My end behavior tells me how to start. It's coming. And then it turns around, goes down through here, turns around again, goes up. This is far from perfect, but that's exactly what I want from you. That's a weird thing to hear a teacher say. If I get perfect, you copied that shit from the calculator. Especially if what I see does not match your work. Do you understand? This is what I was saying earlier. If you do something wrong over here, I want to see you plot that shit. I want the graph to be wrong. I don't know if you understand why. Because part of what I have to grade is, do you know how to put this work into a graph? So you won't lose a damn thing on the graph, even if it's completely wrong, if it matches your work. Do you guys understand? The best way to make sure you're going to lose all the points is if your graph does not match your work. And then it's like, perfect, screw that. Especially love when people give me this answer. They give me something like this. Here, here. I don't know if you understand, this means they didn't put the window high enough on their graphic calculator, so they didn't see where it turned. I'm like, make my job hard if you're gonna cheat. Put some effort into it. It's a lot more effort to cheat and get it past me than it's just to do this shit. Okay. Let's do another example. And I want to point something out. Each of these, each term right here, what power do they all have? That sounds weird, but what's the power? First power, correct? So would you agree that each piece of this is linear, is like a straight line? What does a straight line do when it hits its x-intercept? Does it turn somehow? It just keeps going, correct? What did we do through each of the intercepts? We went through. Didn't I go through each of the intercepts? I didn't turn at any of them. You guys with me? So let's do a problem where I get something that turns and we talk about why.
Wait,
Oops, sorry. What's up?
What do you mean by
Each of these terms. What's the power on each of them?
1?
1. So they're all an odd power. What's the only kind of power that would make something turn?
Even.
Second.
Even. X squared, x to the 4th. What does x to the 3rd do? Doesn't it go through its intercept? You guys with me? X to the 5th would have the exact same shape. So all the odd powers are going to go through. All the even powers would turn.
Oh, okay.
So all the
Yeah.
even powers are not going to pass the
All
horizontal line.
Yeah, they can't go to the other side. I'm not sure if that's what you're saying. Yeah.
So the way to say that, it's called like bounce or something like that, right? The bounce off the x-axis.
Oh yeah, sure. There's a lot of different words you can use. You can use bounce, you can use turn. There's 2.
Do you have
So
a
many.
specific one you want to see?
We'll see. I use through and turn. But if you like bounce, you can use bounce. Okay. So what about, I'll give you guys one that's already factored. Sounds nice, Jeff. Now the nice thing with this is, I could see the x-intercepts. The mean thing with this is, you can't just see the end behavior. I need you guys to really understand. If I multiply this shit out and don't. If you get a problem like that, do not multiply this out. It's a gift.
Wouldn't it be x to the third since?
No. If I did multiply this out, what would the highest number of x's I get?
4.
4. There's 2 in front. And then, if I multiply these together, don't I get x squared?
Yes.
Times x squared is? So the highest power I would see, if I was silly and multiply this out, is 4. Do you have to multiply it out?
No.
Shit, no. Please, dear God, don't.
And it's a fourth degree polynomial.
So this goes like x to the 4th. What would the end behavior be?
Oh, no.
Up. Yeah, looks like a parabola. Let me stop for a minute. You guys with me? Do you guys see that? When I factor stuff, for example, when it's factored, is it really quick to see the y-intercept? Normally, no, right? In this problem, again, Jeff, good job. I made a problem. Can anybody see the y-intercept? How do you find the y-intercept? You make x0. So what do you get when you make x0? Look at the very first term.
You get 0.
You get 0, right?
I 0.
So the y-intercept, one more time, is 0, 0. What are the x-intercepts? 0, 0. Negative 3, 0. 5, 0. Now, real quick, before I even tell you the word for this, which one of those will it turn at or bounce?
0, 0.
Why is it going to bounce or turn at 0, 0? Because it came from a second degree. It came from a part that looks like a parabola, right? What does it do at parabola? What does a parabola do? It turns. The other two pieces came from things that are to an odd power, and those go through.
Did you use the midpoint formula?
No. Turn or bounce, whatever you like to call it. And these two would be through. What does that mean? That means when I start to graph this, it's going to turn at 0. That's exactly what it means. It's crazy. All right, so watch. So I already know the x-intercepts. Y-intercept is not very useful. I can't make my y scale yet, but I can plot my intercepts. So you got an intercept of 0, 0, got an intercept of negative 3, 0, and an intercept of 5, 0. Oh shit. Now, real quick. I could do a rough sketch of this without plugging shit in. I'm going to do it right now. Where do I start over here? Where do I start? What's my end behavior tell me? Am I coming up like Jaws, or am I coming up down from the sky? Down from the sky, right? You guys see that? What am I going to do at this point? Go through. Yeah. And then I'm going to turn somewhere. What am I going to do at 0? I'm going to turn. You with me?
Yes.
And then at some point I'm going to have to turn and come back up. And what I'm going to do here? Go through. Does that match with my end behavior?
Yes.
Yes. Yes. Now, real quick. This is a really rough sketch. And normally that's not what I want, but I just want to show you. I can get I know it's going to look like a W.
But if you just plug in.
What am I not certain about? Yeah. Am I sure about how deep that is? No.
No.
How could I determine how deep that is?
Plugging in a point from the graph.
So plug in either -1 or -2, right?
Mm-hmm.
So you plug in -2, and how can you determine how deep that is? Plug in like 2 or 3. Just like we did a minute ago, yes? Okay. Okay, so let me give you this. that I've been carrying around for a while. You got that? I need this. So very quickly here, let's look at this one real quick. This one's nice because it's not factored yet. So factored is awesome because factoring, it can get gross, but also you lose information when you factor something. It's very easy to see the end behavior of this function, yes? What would the end behavior of this be?
The parabola.
Huh?
Smiley face.
Oh, smiley face, yes, it'll be up. So since it goes like x to the fourth, it's going to be.
That's it.
That's for the first part. Right? End behavior is pretty quick. If you could just determine what the highest power would be or is. How do I factor this thing?
Well, you can't
Take
split
out the
it.
X.
Where do you go? Yeah, what do you always try first, of course?
Just come back.
GCF, I love it. So what's left there?
X squared, parentheses, x squared plus 3x minus 10.
Yeah, just everybody loses 2 x's because you're taking 2 x's away. And then I've uncovered something.
2 and 5.
Yeah, so it'll be x. 2 and 5, which one is which?
It's
It'll
going to
be
be negative 2, positive 5.
Yes. So again, I'm just fascinated by 0, but what would the x-intercepts be?
2.
0, 0.
0, 0.
why is it 0, right?
Negative 2, 0.
Careful. 2, 0. So you're asking yourself, what would make this 0? 2 would make it 0.
Oh.
What would make this 0?
Negative 5.
Negative 5. Now, the word we use for a term where it's going to bounce or turn is multiplicity. Does everyone agree with me that that 0 shows up twice? Because what did it come from? It came from x squared. So for each x, I can make it 0, and it would. So I got 2 0 answers, right? So the multiplicity of 0, 0 is 2. It's just the power that's on it, to be honest. That's all it is, yeah. It's just the word we use. So what's the degree of the term that I got 0 from for the x-intercept? What's the degree of the term that came from? 2. So what's the multiplicity of that root? 2. So it's just another word we use, right? Yeah. So the multiplicity of 0, because it shows up a multiple number of times. It shows up twice. So we call it a multiplicity of 2. And what's the multiplicity of the other 2? Even multiplicities turn, because it's just like a parabola. Odd multiplicities go through. Even turns, odd goes through. The 0, 0 term, where did it come from? The 0, 0 intercept, where did it come from? Which piece? Which piece told me 0?
Squared.
X squared, isn't that a parabola?
Oh.
Would it turn?
Yeah.
Okay. The other 2 are first powers.
Yep.
They would go through. I like it. That's really, it's crazy. That's all it is. It's crazy. So it's going to go, it's going to turn or bounce, whatever you want to call it here, and it's going to go through and through. So I basically did this work here. I like it. And then you do exactly what we did earlier. You can plot your intercepts. my, good,
These are the roots on the side.
yes.
Okay.
These are called roots, they're also called zeros.
What's the multiplicity of a root?
The power of the term where it came from. Right. So where did the 0 come from? X squared? Powers 2, multiplicities 2. Yeah. So where's my end behavior say I would start from over this side? Am I coming
Going
down at
down.
this or am I coming
Going
up?
up.
Here, come down.
What's my end behavior say?
Oh, going down, it ends up.
Yeah. So it's gonna come down. I'm turning at 0, 0, so I'm gonna go through this. I can then figure out where did I put that? Yeah, a few more points. What would be a good point for me to figure out in the middle? Negative,
Yes,
say again?
negative 3.
3? Beautiful. So if I figure it out, I can see how deep this is gonna be. Then it's gonna turn, and then what's a good point to plug in over here? To see how deep it's gonna be? 1, yeah. Alright, I'm pushing my luck here. So I tell you what, you got the practice test right. We'll finish this thing up first thing on Thursday. I'll have the answer key for the practice test. We're obviously not going to get to section 3, I'm sorry, 5, 4? The division one?
So all the way up to section
5, 3, yeah. Yeah.
and then the extra credit is also due by the time?
I don't think there's any extra credit. The sections I made extra credit were which ones?
5, 7.
5, 7, that's not even, we're not there yet. Yeah. So ask me that question when we get there. So another name for zeros is yeah, because they are the things that make the function zero. So we call them zeros. We also call them roots.
What was the y-intercept of that?
Well, the funny thing is anytime you have an x, there's like 0, 0, it's also the y-intercept. You can't have more than one y-intercept or else it wouldn't be a function, right? So,
Thank you.
you're welcome. Cool, yeah, don't forget your IDs, dear God.
Did I see the notes that you did for the point plotting?
Say again, sorry?
The notes for the plotting points?
Which one, sorry?
The,
This one.
yeah,
Okay.
and then the other two we got.
You got the practice test. And then this one. Oh, okay. No, sorry. Can't. Great. Okay. Sorry, you can't touch it after it's printed.
What can I turn this in? Homework?
Right there. Cool. Homework. Sweet.
Just stay
Grab that phone from me. Thanks, man.